Hi AB Calculus students. We're working on 2013 question number 4. This is a FTC question. That just means a fundamental theorem of calculus question. And they once again have given us a graph of a derivative. They're saying this graph is called f prime. Now remember, we like the graph of f prime. You make a sign chart of this, and it will tell you when f is increasing, decreasing, maxes, and mins. And if you make a derivative sign chart of its derivative, the second derivative, looking at slopes, you can learn about concavity and points of inflection. Okay, so let's go ahead and do part A. When does f have a local minimum? Okay, well, let's make a sign chart of f prime x. So we go from 1 to 8. This is f prime x. On a sign chart, we want to know when is something equal to 0. It equals 0 at 1. 4 and 5, I think? Nope. At 1, at 4, and 6. Okay, and now notice we have positive values, negative values, positive values. Positive, positive, negative, positive. Okay, now these are all where f prime x was equal to 0, so f of x would have horizontal asymptotes. Horizontal asymptotes means they could be maxes or mins or neither. Anyways, so at this point right here, f of x would have been increasing and then increasing, so increasing, increasing some more. That's not a max or a min. Here, increasing then decreasing, that's a maximum. And here, decreasing followed by increasing. That's a minimum. And I believe in this question they want to know when does it have a minimum. So we would say relative minimum at x equals 6 because f prime x changed from positive to negative values. And that's it. Let's go look at the second question. The second question, they want you to find the absolute minimum value of f on the closed interval. Okay, now I'm going to use this sign chart to help me figure out who can win the absolute min and max awards. All right. So this is part B. Okay, now look at what this tells me. F of x, we don't know where f of x starts at. We know it ends at 4. But anyways, f of x was increasing, increasing some more, decreasing, and then increasing. So f of x went up, up some more, down, and up. Now, looking at these values, where could f of x have an absolute minimum? The absolute minimum could have occurred here or here. It could be endpoints or critical points, but this endpoint here couldn't have won a min, it could have won a max. This right here could have won a max. This one right here wasn't winning anything. Okay, so the absolute minimum value could occur at f of 0 or f of 6. So I'm going to list my candidates. So candidates for absolute minimum are f of 0 and f of 6. So if we can find those values, whichever one's lower is the absolute minimum. Now, remember, these plus signs tell you that the graph was increasing, but if you want to know how much it was increasing by, the area, the actual area here, area of 2 told me the graph went up 2. Area of 6 told me it went up 6. Area of 3, down 3. Area of 7, up 7. So we can use that information to help us find out how much things went up and down. And let's just work backwards. We know where we ended up. F of 8 was 4. We're going to do this whole problem different in just a bit. But right here at 8, it was at a height of 4. Now if you work backwards, remember if you're going backwards, you're subtracting. So we're going to go down 7. So that area of 7, actually, because we're working backwards, we're going to go down 7. If you subtract 7, you're going to be at negative 3. And then here we've got 6. So again, sorry, we're going from 6 to 4. From 6 to 4, we're using this. 3, we're working backwards. So if we go up 3, we're at 0. And then down, we're going backwards. So 6 and then 2. 6 and then 2. So if it goes down by 6, we're at negative 6. If it goes down by 2, we're at negative 8. And at the end of this problem, we're going to say f of 0 equals negative 8 is our minimum value. And I just wanted you to see how you could kind of use the sign chart and our starting point, which is actually our final point, to work backwards. Okay, so we're going to work this out officially like we do in class. And we're going to be doing this. Remember, if somebody said, what is f of 6? And the only thing we know, the only starting point we have is f of 8. All right? Look at these two. This one comes later. This is my final position, and I want to know my initial position. So if you want to know your initial position, it's the final position minus the net change in position. So what I want to do is I want to, again, initial position, because I'm working backwards, I have my final position. So my final position is 4, f of 8 is 4, minus the area from 6 to 8. Well, the area from 6 to 8 is 7. So 4 minus, wow, why did I change that? It's supposed to be a 6 still, sorry. So 4 minus 7 is negative 3. F of 6 is negative 3. So these are my candidates. I now can say f of 6 is negative 3. And now I'm going to go back and find f of 0. All right. Well, f of 0, 0 comes before 8, so f of 8 is still final. F of 0 is initial. So it's still final minus net change, but now the net change we want is what's the net change from 0 to 8. So what's the net change, or what's the area from 0 to 8? Well, let's just look at the area from 0 to 8. It's 2 and a 6 and a 3, but because it's below, it counts as a negative. So it's 2 plus 6 minus 3 plus 7. That's how I would find the area from 0 to 8. So if I put all those together, 8 minus 3 is 5, that's 12. And if I do 4 minus 12, I get negative 8. So I say the candidates for absolute minimum are f of 0 and f of 6. F of 6 is this value. F of 0 is negative 8. You just compare them, which one's lower. So I would say, therefore, the absolute minimum is at f of 0 equals negative 8. Now in this problem, they actually wanted to know the negative 8. But if you're not sure, do they want the x or the y coordinate? You just give them both. But they wanted the minimum value, so they wanted y values only. All right, now that was the hardest part, and it was worth 3 points. Okay, part C says on what open intervals, so we're going to go to part C now. All right, so I'm going to erase this. Okay. So for part C, they want to know which open interval is f of x concave down and increasing. So I'm going to need 2 sign charts. I'm going to go ahead and put this sign chart back up here of f prime x. I erased it. So from 0 to 8, we had a 1, we had a 4, we had a 6, positive, positive, negative, positive, and now we need the second derivative, f double prime x. Now remember, if this is f of f prime x, and we want a sign chart of f double prime x, we look at slopes. So I'm going to look where I have positive and negative slopes. And you'll notice here you have negative slopes until you hit 1, and then positive slopes until you hit, that's 3. So positive slopes until you hit 3. Whoop, I'm trying to make these line up. So I'm going to move my 3 over here just a little bit. Okay. Then I have negative slopes until I hit 5. Right, 1, 2, 3, 4, 5. So negative slopes until 5. and then positive slopes all the way till 8. Okay, now in this problem, they want it to be increasing. That means f prime x is positive, and they want it to be concave down. And concave down is, making sure that's correct, is when the second derivative is negative. So I want this one to be positive, this one to be negative. Notice that happens here. So increasing and concave down on the interval 0 to 1. Let's see, does it happen again? A positive with a negative also happens right there. And from 3 to 4. It does not happen again. So on 0 to 1 and 3 to 4, because, and I'm just going to say, f prime x is positive, and f double prime x is negative. So that's all we were looking for. Increasing, concave down. Increasing, f prime x is positive, and concave down, f double prime x is negative. And we wanted to know when both were occurring. All right, that's part C, and now part D. All right, part D, if f of 3 equals negative 5 over 2, find the slope of the tangent line to the graph of g. All right, slope of the tangent line comes from the derivative. All right, so let's look what they gave us. They gave us g of x equals f of x to the third, and we would need to know what is g prime x. Now, imagine it was not f of x to the third. What if it was 2x minus 1 to the third? What would you do for the derivative? You'd bring the 3 to the front, da-da-da-da-da-da. Exponent would go down by 1 times chain. And that's the same idea when we take the derivative here. The 3 is going to go to the front, da-da-da-da-da-da. The exponent goes down by 1 times chain. The derivative of f of x is f prime x. And now they want to know, okay, well, what is the slope of the tangent line at 3? That means what's the derivative at 3? So I'm going to replace that x with a 3, and that x with a 3. All right, so my final answer, we're about ready to get those points, is going to be a 3 times something squared times something else. All right, so first of all, what is f of 3? F of 3, they told us. That's the negative 5 over 2 number. So f of 3 is negative 5 over 2. And then we need f prime 3. And the key is to understanding what in the world f prime 3 means. All right, f prime 3 means what's the slope of the tangent line at 3? Am I right? No. Oh, this is the graph of f. This is not the graph of f, this is the graph of f prime. Oh my word. So f prime 3 literally means, if this is the graph of f prime 3 is the ordered pair. On the graph of f prime, when the x is 3, what's the y value? It's 4. Because this is the graph of f prime of 3 is simply the ordered pair. If it's a graph of f prime, we want f prime 3, you're just looking at ordered pairs. It's 4. Put a little 4 there. F prime 3 is 4. And I'm done. Remember, we are not simplifying stuff here. So that's your answer. It looks great. Do not try to simplify it. You simplify, you mess up, you lose points. And that's the end of that question. Thank you.